The least cost rule states that in order for a business to make a certain amount of product for the least cost, they should hire a combination of resources such that the last dollar spent on each resource yields the same marginal product. Blah, 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 blah. For example, we will assume some business, like a mint chip ice cream business, wants to make about 270 gallons of mint chip ice cream, and they can use either labor or capital to make this output. Let's also assume this business hires its resources in a perfectly competitive resource market. That means each successive unit of a resource can be hired at the same price as the last one. So each time they hire a worker, they can pay every worker the same amount, $20 in this case. They can also purchase capital, like some machine that makes their ice cream, at a constant price, $60 per machine in this case. The table of productivity for labor and capital for this business looks like this. So the least cost rule says that if a business wants to make a certain output, like in this case 270 units, they should hire resources in a combination such that the marginal product per dollar spent on one resource is equal to the marginal product per dollar spent on the other resource. So now I'm going to add columns to this table, one for marginal product per dollar spent on labor, and another for marginal product per dollar spent on capital. The marginal product per dollar of the first worker is 3 units per dollar, since the marginal product is 60 divided by the price of that labor, which is $20. The marginal product per dollar of the first unit of capital is 2 units, since the marginal product of 120 units is divided by the price of the capital, which is $60. Then I fill out the rest of the columns. If my goal were to make 60 units of output, the least cost way to do it would be to hire one worker, since that worker will yield 3 units per dollar spent on their labor, compared to buying the machine, which only yields 2 units of output per dollar spent on the capital. But my goal is to make 270 units of output, not just 60 units. So in order to make more output, my next decision is to decide if I should hire the second worker or buy the first unit of capital. Since the second worker yields more product per dollar spent than the first unit of capital, I would hire the second worker. And with 2 workers working, I make 110 units of output total. That means I still haven't hit the output target of 270 units, so I keep going. In comparing if I should hire the third worker or buy the first unit of capital, I find that the output per dollar is the same, and so I hire the third worker and buy the first unit of capital. This will result in a total output of labor of 60 plus 50 plus 40 units and a total output from capital of 120 units. 150 plus 120 equals 270 units. Voila! I have found the least cost way to produce 270 units by hiring 3 workers and buying 1 piece of capital. Notice how least cost is simply a way to find the least cost combo of labor and capital to make a set amount of output, 270 units in this case. Notice also that the method of moving down the labor and capital columns was in such a way that we got closer and closer to the marginal product per dollar of labor being equal to the marginal product per dollar of capital, and in the end, they were both equal. So the least cost rule is used to find the least cost way of making a set amount of output. However, how does a business decide what output to make? Remember that a company's goal is not to operate at lowest cost. A company does not choose to make the minimum ATC quantity. No siree. A company's goal is not to operate at minimum per unit cost. Their goal is to gain maximum profit. And they find that output at the place where MC equals MR. So I'm going to pretend this is a perfectly competitive seller, and here's their demand equals marginal revenue curve. So to maximize profits, this seller will make this output, Q sub 2. When they make Q sub 2 output, let's say 270 units, they will want to make those 270 units using the least cost combo of labor and capital. There are many possible outputs for a business, and each one of those many possible outputs has a least cost way of making it. There is, however, only one profit-maximizing quantity of output. To find this output from information about productivity of various resources, a business would follow the profit-maximizing rule. The profit maximizing rule states that a business is employing a combination of resources in a way that maximizes their profits if the marginal revenue product of the last worker hired equals the marginal cost of that last worker, and the marginal revenue product of the last unit of capital purchased equals the marginal cost of that capital. Blah, 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 blah. I'll explain that. But before we look more closely at the profit maximizing rule, let's compare it to the least cost rule. Notice how in the least cost rule, you only need to be comparing the marginal output per dollar of labor to the marginal output per dollar of capital. But for the profit maximizing rule, we are comparing the marginal revenue product per dollar cost of labor to the marginal revenue product per dollar cost of capital. Also notice that if a business is going to be profit maximizing, the marginal revenue product of labor divided by the marginal cost of labor must equal 1. And also, the marginal revenue product of capital divided by the marginal cost of capital would also have to be equal to 1, basically meaning the numerators and the denominators of the equation must be equal to each other. And this must be the case if a business is profit maximizing. If you look back to the notes you just took on least cost, you will see that we found the least cost way of making 270 units of output was by hiring 3 workers and buying 1 unit of capital. In that situation, the marginal product per dollar of the third unit of labor equaled 2, and the marginal product per dollar of capital also equaled 2. Since they both equal 2, we satisfied the conditions of least cost. But that is not necessarily satisfying the conditions of profit max. Let's go back to this table of information from before. But instead of a marginal product of labor per dollar column, we put in a marginal revenue product per dollar column. And instead of a marginal product per dollar column for capital, we will use a marginal revenue product per dollar column for capital. Now, the price of the labor and the capital is still $20 and $60 respectively. And let's say for simplicity's sake that this seller sells their output in a perfectly competitive product market so that they can sell all they want of their product at a fixed price. We'll pretend that this fixed price is $2 per gallon. Now, I'm also going to add a marginal revenue column for both labor and capital. I can skip finding total revenue and then change in total revenue only because we made the assumption that this is a purely competitive seller who sells all the product they want at a set price of $2. Since all additional units can be sold for the same $2 price, we can multiply the additional output of each worker or machine by the product price to find the change in total revenue. Please note, however, that we would not be able to follow this shortcut method if we were examining an imperfectly competitive seller that had to lower their product price to sell additional units of output. Okay, so now that I have my marginal revenue columns in, I can fill in the information. When the first unit of labor makes 60 units of output, the change in total revenue will be 60 times $2, which is $120. When the second unit of labor makes an additional 50 units of output, those can all be sold for $2 each, so the change in total revenue is $100, and so on down the column. Now I'm going to do the same for capital. The first unit of capital adds 120 units of product, which each sell at $2, so change in revenue is $240. The second unit of capital adds 80 units of output, so the marginal revenue of the second unit of capital will be $160, and so on down the column. Next, I calculate the marginal revenue product per dollar spent on labor. So the marginal revenue product figures will come from this column, and the price of labor is $20 for every worker, since we assumed we are hiring labor in a purely competitive labor market. When I fill out the column, it should look like this. When I do the same for capital, I'll use this column of information for the marginal revenue product of capital. And since we are also assuming we purchase capital in a perfectly competitive resource market, the price of every additional unit of capital is fixed at $60 per piece of capital. So the calculations for this column would look like this. Given this information and following the profit maximizing rule, how many units of labor should the business hire and how many units of capital should they buy? Well, they should hire 5 workers and buy 4 machines. The reason they should buy only 4 machines is because if they purchase the 5th machine, the marginal revenue product of the 5th machine would be less than the cost of the machine. That means that the bad news, the cost of the machine, would be larger than the good news, the marginal revenue product the business gains because of that machine. Whereas at 4 units of the machine, the good news is still bigger than the bad news. Okay, so now that we know the profit maximizing combo of labor and capital is 5 workers and 4 machines, how much output will this profit maximizing seller make? Question 2. If the product price went down to $1, what would be the profit maximizing combo of labor and capital then? Number 3. If instead of the product price decreasing, the price of capital increased to $150 per machine, how much capital would the profit maximizing seller purchase? Pause the video, please, and try to work out those 3 questions before looking at the next part of the video, which will give you the answers.